Alright, welcome. This is Mrs. Nagle's solutions on how to solve uniform acceleration motion problems. Alright, first thing you do when you look at a problem is you got to figure out your knowns and the unknowns. So I like to circle exactly what I know. This is a velocity. So I know it says it lands, which is a little weird, but this is initial velocity. Circle it with the units. It stops. That's information about my final velocity. My final velocity is 0. I don't know if I'm going to be able to circle that. At the end of a runway that's 500 meters long, that's my distance. And it asked me to find its acceleration. Well, first, if you notice, are you given 3 variables? Well, yes, I am. So what are my variables? I'm given V initial at 300 meters per second. My V final I'm given, which is 0, because I stop. And my distance is 500 meters. Okay, so now I got to figure out which equation I'm going to use. Why do I need 3 variables? Because I'm given 5 variables total. And if you have less than 5, you'll have to do simultaneous equations. And it gets tough. But for Regents physics, 3 variables will get you answers. I had a student ask me why 3 instead of 2. You wouldn't be given enough information. 4 is great. You have more than you need. All right, but 3 will enable you to solve it straightforward. All right, so now I have some variables. What do I not given? What am I not given? I am not given time. So I'm going to put time is not given. So this tells me some really important information. Because time is not given, that means I look at my equations and I cross out ones that have time. So this one has time and this one has time. Because I'm not given time, I can eliminate those 2 problems, or those 2 equations to use. So now I look at my third equation. I'm given initial velocity. I'm given A, I'm trying to find, but I'm given D, and I'm given final velocity. So I have enough information to solve for my acceleration. So since I'm looking for A, I'm going to just go ahead and plug in what I know and what I don't know. Yes. All right. All right, so my equation states that V final squared is equal to my V initial squared plus 2AD. Now, if you want to make an observation here, the plane has speed and it slows to a stop. So that acceleration would be deceleration. So that should be negative at the end. So that should be a clue for us for later. All right, so let's plug in what we know and what we don't know. I'm going to put my V final, which is 0. Squared it, but 0 squared is still 0. My V initial is 300 meters per second. I square everything. Plus 2. I don't know what my acceleration is, so I leave that A. And now my distance is 500 meters. All right, moving forward, I'm going to try to get the recorder way far away, up to here, I guess, covering my airplane. Plug in my numbers. I'm just trying to get further along. So 300 squared would be 90,000 meters squared, seconds squared, because the squares go into all the parts, even the units. Now I'm multiplying my 2 and my 500 together, and I'll get 10,000 meters times my A, which is the acceleration. Not really looking good here yet. I got to get my A by itself. So how would I do this? You're going to subtract 90,000 from both sides. Meters squared, seconds squared from both sides. Notice, this is kind of cool. My negative sign is now showing itself. So now I have 90,000 meters squared per second squared is equal to 10,000 meters times my single variable A. I'm going to write that in a different color. How do I solve for A? I have to divide by 10,000 meters, both sides. 10,000 meters, both sides. Watch the units. This M cancels with one of those M's. So now my unit is a meter over a second squared, a meter over a second squared. And this divided by the other one would be A, another right, squeeze it in here, A is equal to -9 meter per second squared. All right. Okay, so the student asked, where did I get the 10,000 from? I multiplied 2 and 500 together, and that gave me my 10,000 meters. And notice you can multiply it in any order, so now I've put out the A on the other side. Is that clear? Okay. And remember, I wanted to make sure I had acceleration. I wrote it's supposed to be only that, right? Sorry. Dang it. So now I have to go back, get rid of all my zeros. So this makes it 90 meters per second. Is this correct? 1, 2, 3. Yeah, so I have 90 meters per second.